So hello. Thanks for coming. As it was just said, I'm Andrew Harmel-Law. This is Gayathri Thiyagarajan, which I think I've said properly. We're going to talk about our experiences working together on one kind of big project, but a bunch of other little things that we've done in the past as well. But the theme is about kind of the complexities and benefits of using domain-driven design at scale. And we're going to use a kind of lens of looking at things, which was suggested to me by an ex-colleague called John Barber. So it's a Buddhist concept, but there's no religion in the talk. But it's a really interesting way of looking at things. So we'll talk about that a little bit. Oh, it's not. Oh, there it's working. So as I said, I'm Andrew Harmel-Law. I'm a tech principal at ThoughtWorks, although the stuff I'm going to talk about in this talk was when I was in my previous job with my previous employer. So ThoughtWorks, I think folks here in like Europe have heard the ThoughtWorks are in various European countries. At the moment I'm working in Oslo, but I'm doing domain-driven design there. And in my previous employer, I've done domain-driven design as well, in lots of distributed systems projects, with Java EE stuff and microservices stuff, lots of different projects.
And I'm Gayathri Thiyagarajan. I used to work for the same company as Andrew. Now I work for Expedia as engineering lead. I've been a Java engineer for 15 years, working on various projects using microservices and CQRS. More recently, I'm leading a big data capture platform using event sourcing, domain-driven design concepts.
So I mentioned the fact that we're going to use this idea of near enemies to examine a story about some of the experiences that we've had doing domain-driven design. So near enemies is something I'd not heard of, and so we thought it was worth explaining what it is. So as it says here, this is a quote from the internet. Near enemies are counterfeits of what you're actually looking for. So the counterfeit thing is important. So it's just like a counterfeit money. It's supposed to look very similar, and to the at a quick glance or even a quite careful consideration, it looks like it's the thing that it's supposed to be, but it's actually not. And as a consequence, near enemies are unhelpful because the genuine article frees us and allows us to achieve some goal, while near enemies don't and they get in the way. So you might be able to think of some existing near enemies. There's lots of near enemies in the worlds of agile and agile transformations, or if you've been in a DevOps adoption, then you possibly come across some near enemies there. So things like an agile adoption, you'll see lots of people doing the ceremonies. You'll see stand-ups all over the place. You'll see Jira Kanban boards all over the place. You'll see people doing retrospectives. But what you won't see, or see very little evidence of in many cases, is people sticking to and kind of keeping to heart the 4 kind of elements of the Agile Manifesto. If you're doing DevOps, you might see loads of Jenkins builds going on all over the place. You might see automation all over the place. You'll probably see Kubernetes everywhere. But what you won't see is people working very hard to break down the boundaries between the development and the ops teams. You won't see people trying to build a culture of learning and sharing and learning from failure. So again, people are falling into the near enemies. And we're going to talk about some in the area of domain-driven design. So I said we're going to talk about a project. It's kind of based on a project that Gayathri and I worked on, which was in the criminal justice domain. We picked this because we want to talk quite a lot about the specifics of this domain, and because everyone will come from a country which has some form, hopefully, some form of criminal justice system. And despite the many differences that there are globally, the things we're going to talk about are hopefully relatable. And if they're different from your criminal justice system, you've probably watched a North American TV show or a British TV show or a European, maybe a Scandinavian TV show, where people are either police or lawyers and they're doing things in the area of criminal justice. So lots of stuff should be familiar. So the project that we're going to talk about, which we've added kind of extra pieces to, is this project to modernize criminal justice. It was already going before I started, so that's an important fact. And I joined, and I was supposed to be there as the domain-driven design expert. And after I'd been there for quite a long time doing some investigation, Gayathri joined.
So my focus since taking over from Andrew, I spent about 1.5 years on the project. It has been mainly focusing on implementing the models that Andrew had discovered, while also challenging some of the assumptions that he had made. So this theme you'd see in the rest of the talk as well. So he'll speak more about how he discovered those models, and I'll be focusing more on how we actually implemented that.
Another key thing to remember is there was very little overlap. So I got my job at ThoughtWorks very soon after Gayathri started on the project, and then I rolled off. And then a lot later, Gayathri rolled off, but the project kept going. So, there's lots of, we definitely weren't done by the time we finished the piece we're talking about, but we can kind of hopefully share some of the lessons learned. So there's us also, because we're basing this on a project that exists in the real world, there's some important key constraints which are worth pointing out, because again, it makes it more kind of relevant and specific to pull out some of the key problems. So the first thing was, we said we were modernizing a criminal justice system. It was an end-to-end solution, and so we were working with partners across the criminal justice domain. So it wasn't just a court system, it wasn't just a state prosecutor system, it went all the way across. Secondly, as we said, work was already happening. So teams had been identified and code was already cut. There was a lot of code already in existence. And thirdly, and we'll touch on this at the end because it's having kind of built up this, hopefully this example of pretty complicated domain. CQRS was being used in every single microservice in this solution. So what we want to do is talk about, in context, some of the pros and some of the cons of microservices in this specific example.
So not surprisingly, things were extremely complicated already, even before Andrew and me joined the project. But what we quickly realized was the stakes were incredibly high in terms of benefits, because this was a huge public sector project, modernizing criminal justice. If the project was successful, it would have been a really good success story. But also in terms of failure, if it was, the stakes were incredibly high as well.
So I'll now kind of start talking about the things that I found when I landed and the kind of the discoveries we made, some of the pain points that were in evidence already, and we'll begin to kind of talk a little bit about the investigations that I did and some of the hypotheses I came up with. Then in part two, I'll talk a little bit about Gayathri, I'll talk a lot more, where we try and take some of the ideas that I'd had and try and bring them down to the level of teams. And then the part three, we'll talk a little bit about what it was like doing CQRS in this environment. So the first thing I did when I landed on the project was to get as much of an idea of where things actually were and how much work had already been done as possible. So I looked at all the code that I could get my hands on. There was loads of stuff on the wiki, so I tried to read as much on the wiki as possible. There was loads of DDD artifacts in lots of different places. There were guerrilla models that you could see on the backs of whiteboards or kind of lying around. There was also the existing team structure, so looking at how the teams were structured, how they owned the various components and microservices, how they were releasing things, the interdependencies between all of these different things. And I was trying at this point, kind of a key consulting thing, is to not get sucked into any of the detail, and there was a lot of detail, because I wanted to get an idea of the kind of how broad the scope of what we were looking at went. And so I came up with kind of three key things. Number one, there was no single domain expert who knew everything in a detailed, to a level of detail about the overall thing. Then this wasn't a failing. It was absolutely fantastic that someone had gone at the very start of the project and identified domain experts from all of the key criminal justice organizations and had them working with us on the project. The thing was, it was end-to-end, so there wasn't one person you could go to for a pretty good idea of how all of these pieces fit together, because nobody knew. Nobody was an expert in all of these things. What was a bit of a problem, however, was there was loads of detail, but there was no high-level, simple, big picture. Like the kind of the picture of the globe, the very simplified picture of the world behind me here, that was lacking. So you could go and find tons of detail, but to kind of dial out and just say, where's the kind of boundaries of my piece and what does it connect to locally, that was quite hard. And consequently, the cognitive load for everyone on the project was really high. So conversations would get super detailed and super complicated very quickly. You know, they'd always be down in the weeds. They wouldn't be at a higher kind of level. So this brings us to our first near enemy. So the design had been done, and there was loads and loads of it, and it was really good. But it hadn't been laid out in a way that made it consumable. And the combat strategy, make sure that your design artifacts are laid out in a way that they're consumable by the people who need them. So at this point, it was the teams and the domain experts, because they were, you know, the people writing the code were as important as the domain experts in trying to understand how things fit together. So this is all a bit high level. So what we want to do is kind of kick off a thread of a problem, which we then kind of started turning into a solution, which we slowly figured out an answer to to take you through this domain in a way that kind of hopefully something you can understand and kind of see the problems that we encountered in context. And the problem was kind of came to be known as a case is a case is a case problem. So you'd hear this phrase, I think you actually hear the phrase a case is a case, but we added the extra case on because it was quite funny. There was this kind of, because remember we're modernizing justice, so people were trying to find abstractions and kind of key ways to think about things. And the fact that a case would manifest in different ways in different systems, but it was always still the same case. It was always still me being prosecuted for a crime. That was this one unifying idea. So therefore, as you would expect, there was a repository with a class in it, which was a case aggregate. And because it was shared, it was kind of super central, it was shared by loads of different teams. So therefore, it was deployed as its own individual microservice. And because it was deployed as a microservice, it was in its own repo, which was shared by lots and lots of teams because they'd all need to add their little bit of functionality to the case aggregate. So what we'd fallen into here was the trap of thinking something that was similar was the same. And there were loads of different instances where lots of conversations could be had across various stakeholders in the project where they would talk about a case and they would agree. But the things they were agreeing on were the things that were similar, but they could also disagree when they talked about very specific elements of very specific needs they had for a case. But those differences, which made something similar and not the same, had been lost in this kind of one unified case is a case view. So we can give a really simple example, and again, we'll build this up as we go through. And so this example thinks about the various kind of people who play an important role in the case. So if you've watched TV shows, you'll recognize the fact that if you're watching a police-driven TV show, the person will be the suspect. They're chasing the person. They're trying to either identify who the suspect is or they're trying to catch this person. Then, if you're watching a later show, maybe in the same TV series or a different kind of show, you're watching a legal drama, the same human being will now be a defendant. So it's the same human being, but with regards to the case, they're very different. But they're not the only important people that you'd expect to kind of find in a case. You also expect to probably see witnesses, because not all crimes have witnesses, but the majority do. But crimes definitely have victims, and crimes typically have an investigating authority, maybe the police, maybe someone else, but someone like the police. And each of these, not only will they have kind of important information that they will need to represent with regards to a case and with regards to processing a case, but they'll also have case materials, which might be, for example, pieces of evidence or witness statements or victim statements in certain legal systems, which are, again, there's a very specific relationship between specific instances of case materials with specific people who are playing roles in a case. So if we're, this isn't necessarily what you would expect to see in a code base, but something like this you would expect to be kind of evident. Unfortunately, it looked like this. So they were all people, so we had a person class, person aggregates, where person events were fired, and if you wanted to know if that person was a witness, you need to look in case to see what the witness attribute, which person that pointed at, the same for defendants, the same for police, etc. So we'd lost some of the richness of the domain. And because, like we said before, case was a separate microservice because it was super shared, so was person. So person was a separate microservice as well. So not only would lots of the richness kind of disappeared into best associations, now we were having to look at pieces across two different code bases and two different repositories to find out where this kind of domain information was. So now we get to our next near enemy. So similarities have been spotted, which is good, and abstractions have been made, but we'd lost the important differences. The differences and the potential to represent them had gone away. And so what we needed to do is to capture the richness in the domain, and we do this by not abstracting too early.
So one direct impact of this case-to-case doctrine was the whole architecture and the platform had become distinctly data-centric. The process and the behavior was left out. This directly manifested as merge conflicts between different core feature teams, because there was this, as Andrew pointed out, one gigantic case microservice and one case class that everybody had to converge on in order to deliver anything. Because these are core feature teams, you can imagine case was the center of every feature that they developed. So in order to work around this merge conflicts, the teams came up with a very ingenious idea So they came with a baton, which was like a physical rolling pin. So any team which held the rolling pin were the only ones who were allowed to merge. Of course, this actually resulted in a lot of physical conflict to get hold of the rolling pin. So we secretly resolved that we'll qualify the success of our endeavors if we got rid of the rolling pin. That means we have changed something. But also, there was another hidden problem here. The other core entities that Andrew mentioned, such as the defendant, the case materials, they were still left outside. And the teams had to battle with diluted models because these are very common, shared between teams, which shouldn't be, sharing such a core entity. So they had to deal with a very diluted model. They can't add any richness that their own context actually demanded. So our next near enemy is a data-centric view, which had been achieved by compromising process and behavior. So this also resulted in conflicts between teams. So in order to combat that, share only when you absolutely have to, and it is, Andrew would go into that in a detail, only when it actually is driven by the domain itself. Let's pause a moment and summarize the core modeling problems that these teams were facing at this point. So one model to rule them all principle, even though it was born out of a valid desire not to duplicate data, seemed to be driving a lot of complexity on the project. Design decisions, and very importantly, trade-offs were made with only part of the domain information. Similarities were identified, and the differences were set aside. Finally, models were only about data. Behavior was left out.
So before we kind of come to the end of the first part of the talk, there's one other thing that is worth mentioning. So I said that I was brought onto the project as the DDD expert, which is questionable at the best of times, but it's also a bad smell for other reasons. And then when I left, Gayathri replaced me as the next DDD expert. There already had been someone who'd been the DDD expert before me, and lots of the good stuff that was there had come from that person. But there was a problem around about the definition of what this DDD expert was supposed to do. I was there to do the domain-driven design. I was there to speak to the domain experts. I was there to kind of bring models together. I was there to make wrestle with UML, draw lots of diagrams, come up with my own modeling breakthroughs, but I very definitely wasn't supposed to be writing any code. I wasn't supposed to be hands-on with the teams. I wasn't supposed to be kind of nurturing their domain-driven design skills. I was there to do the domain-driven design, do the work of the design. So fundamentally, it was me standing in front of a whiteboard a lot, trying to figure out guerrilla style, doing as much as I could with teams, like reading existing code and kind of seeing if I could pair with people a little bit when everyone wasn't looking. But I wasn't there to kind of sit down and try and actively solve problems with the code. So the problem reached a peak when I went to a meeting when I was referred to as the domain-driven design messiah, which was a really bad smell. So then at this point, I knew that things were problematic, and I set about fixing them, but it was with Gayathri that they actually started to change. So the near enemy here is kind of obvious. And I knew that it was a problem. The hands-on modelers weren't hands-on. I wasn't hands-on. I wasn't manipulating my models. I was doing all I could with whiteboards and little bits of coding. And I definitely wasn't getting the design breakthroughs I needed because I wasn't getting to sit down with the code and try and solve those problems. And the combat strategy, which I began to work on and Gayathri was far more successful with, was that everyone needs to manipulate the code and everyone needs to do the design and the modeling. And again, the key factor, if someone doesn't know how to code, that doesn't mean they can't do this work. That means they should pair with people. So domain experts could pair with developers, and they still get to bring their knowledge to bear.
So clearly, one person doing all the modeling was not a great idea. But what about the other side? What about the developers and the teams who are supposed to be modeling and implementing this in the code? What were they doing? So this is when we both realized that domain-driven design on the project was something of a directive from the top, and it was more like a must-be-done step rather than something that grew organically. Also, it needs to be mentioned that some people on the project, some developers had tried but failed miserably to implement domain-driven design because of various tensions between different groups of people on the project. Classic example being there was a distinct group of architects who wanted to take control of these models, govern, and be the gatekeepers of who changed and how it was actually rolled out to the other teams. So this ran into the danger of domain knowledge being restricted between a very selected elite group of architects, but not something that was shared across the team. Which brings us to the next near enemy. DDD being done to the teams rather than by teams is something we should endeavor to avoid. So in order to combat that, modeling should be done by the team who are responsible for implementing that as well. But it's also important to grow these DDD practices organically rather than forcibly.
So that's the end of part one. Before we go into part two, we wanted to make sure that something was super clear. So, and there's a good reason why I'd like, so there were many lucky things about the fact that we worked on this project and it was in the legal domain, and that we'd worked on other projects in the legal domain as well. It's because, legal domains are an incredibly complicated place to work. There is just the concept of law in whatever kind of legal system you're in around the world, and there are very many differences, which I've seen by managing to imply to Scottish legal process people that the English legal system is the same as the Scottish one, which is obviously not, I was told. But there's some key complicated things which are implicit or inherent in legal processes around the world. And so these things are, for example, the primacy of the concept of time, which is always important in software systems, but in the legal system is really important. So you'll have laws which are in force now, laws which will be enforced in the future but aren't enforced yet, laws which were enforced in the past but which someone has committed a crime in the past so they can still be prosecuted for a crime. And then you have time-based things which, when a case moves through a legal system, there'll be various time gates, there'll be various triggers of certain things, there'll be various timeouts of, in the legal domain, where something has gone on for too long so it won't be able to go on any longer. People can be remanded in custody for a certain time, then they need to be freed. So time is super important. Another thing is the systems, if we're building systems for across the criminal justice system, it's necessarily adversarial, or all legal systems that I've come across are adversarial. So you need to balance the fact that things, that different parties are trying to beat each other and trying to win against the fact that you're trying to build a system which serves everybody. And finally, there's two principles which need to be kept in mind whenever you build a system for the law. One is timeliness. So therefore, if as people have learned to their detriment over hundreds of years, the only people who benefit from legal systems going slowly are the rich, because the poor can't afford to pay for it. And they also need to be fair. They need to show that justice can be done, so that if there's a crime that's been committed, then people can be prosecuted for that crime, and hopefully the right decision be made at the end. So given all of this, there's lots of complexity already inherent.
But we know DDD is all about tackling complexity at the heart of software, right? So all of this makes DDD the best candidate for the legal domain.
So with that in mind, let's move on to part two. So we've kind of discovered a lot of things that we've showed you about. There was loads of other stuff, but these are the kind of key things which lots of things, other decisions hung off of. So with all of these things in mind, what we wanted to do is move to the next step, to start trying to tackle some of these problems, trying to start look into them and investigate them and figure out how we might come up with a solution which might solve the problems we've got but not lose the benefits which were already inherent in the designs that were there. So we've already talked about the fact that there was a kind of lack of an overarching kind of diagram or high-level view of everything, but there was this concept of a case is a case is a case. So we kind of pointed out the problems with the case is a case is a case, but we still needed to know, we still suspected, based on the fact that we knew that domain-driven design was a good fit, that we would have lots of models, and knowing about the models was important, but knowing how they were related to each other was also important as well. And so how the pieces fit together was one of the next questions that I started asking myself at this point. So the near enemy is obvious again. Not having any 10,000-foot view is a mistake. You need this if you're working at anything beyond a few different bounded contexts. And the way to combat this, just because one structural big idea is wrong, it doesn't mean that you can get away without one. And looking at the relationships between the models, which we'll keep doing through the rest of this talk, are always key. They're your clues to get to the answers. So we've talked about the fact that there was this case of the case model. So that hadn't just come about because someone thought it sounded cool and they kept repeating it and it caught on in the project. So there were some design forces, and remember we're trying to modernize criminal justice. There were forces which had driven the project towards this kind of solution when we arrived to look at it. And those forces were as follows. Number one, data consistency. So the legal system, and all legal systems are famously paper-based. So anyone who tries to do anything with legal systems always hits a problem with data consistency, because it's always, if you think data consistency in databases is hard, wait till you look at the legal system. If you get data consistency, then you can get better reporting. So then you can start seeing across a legal system, however big or broad or whatever it is, okay, now you can start to kind of see things as they really are, or far more accurately, because you've got a better idea of where things are. And with reporting, you can do planning. And if you can plan in a legal system, remember I mentioned timeliness being important, nobody thinks the law moves quickly. So if you're going to modernize criminal justice, more efficient scheduling of physical resources like courtrooms, but also making sure that the right people can be in the right place at the right time to prepare a case or plead a case or whatever, that's how you get modernization. That's how you better serve the principles of justice. And also, we said it's adversarial. So the theory is if you've got everything in one place, it means you put all your eggs in one basket and then you watch that basket very carefully. There's a problem with this, however, and there's no business domain needs being met in this at all. So what had happened was the architecture, we think, had gone in the direction of kind of making the first four bullets work, but as a consequence, just building software so that I, as a defense lawyer, can see the case against my client. That had become hard because the other stuff had become easy. So we're going to look a little bit more at the specifics to find out how it works. So to kind of figure out how to break things up, I went and spoke to the domain experts. And when you kind of asked them when they talked about a case, what kind of case they were talking about, you started to get a bit more information. So if you spoke to the police, it would turn out that when they talked about case, they were talking about a pre-charge case. So there might be a different word in different legal systems, but something before, here you've got a suspect. They are not a charged person. If you're suspected but you're never charged with a crime, then in the public sphere, that's, it's as if it never happened. But when the case decides to be prosecuted and is passed to a state prosecutor, then it's a prosecuted case. Now I'm a defendant in a case. So now I will have a legal record, even if I'm, there will be records of my case having gone to court or me being kind of not taken to court, but things are different. But this is still before it goes to the court. When it then passes to the court, for example, and this is one case in this system, a simple justice case, which is supposed to move through the system quickly, that's owned by the judiciary. So there's still cases, there's still the same case, could still be me having done something, but they're different and they serve different purposes and they have different kind of structures, etc. So what the near enemy we'd fallen into before was we'd solved one problem, the modernization, at the expense of another, building systems to serve these different kind of user groups. And the strategy to fix this, don't ignore the tensions between problems. DDD is awesome, comes with tons of tools. They're like the Blue Book is full of tools to look at these problems, make them explicit, and then solve all of them without trading things off. And so how would we go about solving this problem? So at this point, I kind of I'd read about abstract cores before, and I'd heard about abstract cores, and they seemed to be the thing that we needed to solve the problem of needing to have a single unified view of a case, but also the detailed view so as a prosecutor, I see a different view of a case and can manipulate it in a different way as opposed to someone who's a judge. Would an abstract core be the thing? Because famously, very few people, abstract cores don't exist very much in the wild because it turns out they might not be real. So what I needed to do was, again, go back to the domain, speak to the domain experts to see if they wouldn't call it abstract core, that's a very technical term, but if they had an abstract concept of a case, and if they did, what was their abstract concept of a case, so that I could separate that out and capture that separately, and it turned out they did. So they didn't call it abstract case, they just called it case, but I've called it abstract case here to make it clear. It turned out that there was an old system where everything had a unique case ID, and when they talked about case ID, they all knew what they were talking about. They all knew it was back to this old system, and they knew that it was unique across all cases, across time, in this legal system. They also always knew who the prosecutor was, so they could get back to that prosecutor. They also knew who the prosecuting authority was and who the investigating authority was, typically the police, but so they could trace back to where this case had come from. They also, and this is when I started realizing this was real and it wasn't me making it up because I just read the blue book, to get over the fact that sometimes if one of them said suspect, the other one said defendant, they would get in a fight because they, the police, the judiciary and the police wouldn't always agree with each other. They used the word subject because then they wouldn't have a fight, right? So they were like, the subject is a real thing. And it turns out that case materials was something that they used so frequently, we'd missed it. At the lower level, they actually talked about pieces of evidence, witness statements, etc. Case materials was something from this level. So this was the abstract core, nice and small, nice and tight, but it allowed them to kind of talk about things at an agreed shared level with their domain language, but then that could be mapped down to and implemented by the specifics. So the near enemy here that we'd fallen into, and this was possibly a way of fixing, was anemic rather than focused abstraction. And the way that we benefited from, because someone had already jumped to focused abstraction and we then had license to kind of dial back and go to the detail and then go back to the abstract. Don't jump to abstraction, distill it down. There's a reason why, and I realized this after I'd kind of done this, there's a reason why whatever it is section of the blue book talks about distilling the domain. You've got to have the details to distill it down. You can't go to the distillation straight away. You need to have too much information and then pull out the pieces.
So this is precisely the point when I joined the project and took over from Andrew. So at this point, Andrew had discovered the abstract core, at least 3 different models for what a case should be. But bafflingly, the problems that were at the point of when Andrew started still existed. The merge conflicts were still there. The rolling pin was very much still there. But also at this point, the teams had enough, so they decided to do something about it. So they jumped straight into, without actually delving into details of or understanding the models that Andrew discovered, they pretty much jumped into refactoring their code. So what you actually expected to see was this model reflected in the code, nicely separated into different microservices and boundaries defined. What actually happened was a team went about just roughly hacking the existing case class into 3 different bits. But what's missing here is the core entities that Andrew mentioned, like the defendants, suspects, case materials. Everything was still left outside because not enough modeling was done prior to this refactoring exercise. So now challenge for me is I need to bring those core entities left outside into part of each of these case models, while also helping them to refactor these properly. This is easier said than done, because there was this big giant case class, and then the first ever refactoring that the teams had done since the project started. So it was very clear that a big bang approach was not going to work. So this brings us to the next near enemy, which is abstract concepts, which mean very little if it's not properly implemented by the team. So it's always important to incrementally work towards the final model. But it's also worth pointing out that do not take the models that were first initially discovered by Andrew at their face value. So always constantly validate and challenge the assumptions while working towards that model. So following this refactoring exercise, one of the feature teams, which is dealing with the simple justice case, were dying to kind of go off and do things on their own. So this newfound freedom was equally dangerous because there was a risk of models diverging irrevocably. So what is wrong with that? It's because there is an end-to-end process, as we saw. Andrew talked about this 10,000-foot view. So that needed the abstract core to be in place and the models following some consistent thread because, as we'll see later, a simple justice case will become a court case down the line, prosecuted case, a pre-charge case becomes a prosecuted case, which means you cannot do that state conversion if the models were not consistent with each other. So now the danger was from silos forming out of these splits. So the near enemy here are the premature splits, which could lead into silos, which are very difficult to recover from. So always think about team relationship, because in this case, the team relationship was partnership, even though the teams were kind of dying to go off on their separate ways. So again, coming back to this 10,000-foot view that Andrew mentioned, again, something that was very much confined to discussions in meeting rooms with the stakeholders who agreed and nodded their heads with everything that Andrew put in front of them. But still, the teams themselves had not realized this end-to-end process and how they all come together in the domain. So because of that, as a direct impact of that, we could see that things had become very complicated, where it could be much simpler, or the other way around, a simple problem had been blown out of proportions or complicated unnecessarily. So we came to refer to these as icebergs and ice cubes. So one example of an iceberg is a prosecution case bundle. So this initially, when I started, this seemed like a very innocent PDF generation service. Given a set of documents, all it needed to do was spit out one giant document, which the prosecutor can then distribute. But this actually turned out to be a very key stage, particularly for the state prosecutors, because this is where they get handed over a bunch of documents, the case materials, like the witness statements, evidences, some of them applicable very selectively to a particular suspect, not to all of them. So the prosecutor then goes through the process of sorting those out, selecting some of the materials. They don't use all of them, and they have to account for the unused material as well. So they then allocate it to different suspects on the case, prepare individual bundles, and then distribute it to the defendants themselves. So obviously, different defendants should get different case bundles. Their lawyers, to the court, police, everybody gets a copy of these. So anything that goes wrong in this step could actually result in the case getting thrown out and a real criminal walking out free. On the other hand, an example of Ice Cube, where something very simple had been complicated to be much, much more. So one example was access control and simultaneous updates to a case. This was also something that the stakeholders and the domain experts were largely afraid of, which was what would happen if a court admin modifies a case at the same time as a state prosecutor, or a defendant changing address details at the same time as a defense lawyer doing whatever defense lawyers do. This actually turned out to be a design smell. So remember, we had this one case class, which had the underlying one single database, so this was very much possible. But once we started implementing the models in their own bounded contexts, clearly defined boundaries, microservices, and the actors who are supposed to just work within those boundaries, this problem actually fizzled out to be absolutely nothing. We didn't have to do a single thing to handle the simultaneous updates to a case problem. So always watch out for pseudo-domain complexity. What's not inherently complex in the domain shouldn't be complex in the code either.
So while we leave Gayathri wrestling with the implementation or complexities of the high-level diagrams I produced, there's one more thing which we've kind of already hinted at, but it was something that to kind of make sure that we ended up, going to complete the journey from finding out the case was insufficient towards some other kind of view. What we needed was an actual proper replacement, a physical end-to-end view. And so this is something which I've stolen. It's literally a thing that Alberto drew, Alberto Brandolini. But it's kind of like the pattern which we ended up using to kind of replace and to show the flow between these different case things. So what I wanted to do was go to, again, because I was very reticent to kind of make these big statements, especially as I wasn't getting to work with the code so directly, make these big statements about the fact that this bounded context is related to this bounded context, without hearing a domain expert say there is an explicit concrete, physical relationship between a pre-charged case and a prosecuted case, or between a prosecuted case and a court case. And so I went to them and tried to find out what language they use for these things, what ceremonies they use for these things, and just to make sure that I wasn't imagining that this was a step, or there weren't other steps that were hidden, etc. And I just kind of not discovered all of the pieces. But luckily, they had not only domain language, but in many cases they had explicit ceremonies, and in many cases the ceremonies were so important that if they went wrong, they'd get written up in national newspapers. So when a suspect was charged, Gayathri talked about things like the prosecution packs. Lots of these things would be produced. There was real things that happened. There was actual business logic that that took a pre-charge case that the police might have, and that would be used to seed a prosecuted case, which was this about the case with the same person, but it was their copy of the case. And the same thing would happen when a case went to court. The prosecuted case, when it went to first hearing, there would be an explicit mechanism where formally, as part of the legal process, the court would be informed that this case was coming up, and they would take their copy of the data and do the things that they need to do with it. And the same for other things like referrals. So a simple case is something which should hopefully, if the person pleads guilty, avoid court. If they say, I definitely wasn't doing 100 miles an hour in a 30 mile an hour speed limit zone, then it goes to court and they have to argue their case with lawyers and things.
But how do we actually show this to the teams who are actually implementing? So it keeps coming back to the teams implementing. They need to understand this end-to-end process. And also, they need to understand this in the context of how these models interrelate and communicate and relate to each other. So this is when you've used context maps. They are great visualization tools to show literally anything that you want under the sky. So this is the like a very simplified version of the context map that I put together, which showed like different models and how they actually are related to each other. So for example, pre-charge case becomes a prosecuted case when at least one of the suspects get charged. But what does it mean in the implementation for a developer who's coding? So that's your starter for the boundaries. That's where the pre-charge case stops existing and creates a prosecuted case when a signal is received that one of the suspect is charged. And this passes all the attributes that is required to create this downstream model in that process. So this was also useful for two other reasons. So one, it became very clear to everyone that we needed these multiple models, even though it was just one case. And the second benefit of showing this in the context map was the teams understood where they fit within the big picture. So they were able to easily relate it to which part of the process they belonged and what was actually coming next. So now into much detail, hopefully not too much detail. So how did we actually implement these different parts of one single process? So we had a couple of options. One was we could have absolutely simulated the real world, where there was this one person who sorted through prosecution notices as they arrived by post, packed them up into different suitcases, send them off to magistrates' court or other higher courts. Or we could have made use of some benefits of doing architecture and done this in a slightly more optimized way, which I believe we ended up doing, which was we know when the signal comes in, when the external request comes in, what sort of prosecution it was. So we would just redirect it to the appropriate microservice and at the edge, and then let the rest of the process. We saw the state transformations through the microservices. We just let the end-to-end process take its course. So while we were asking and prodding and asking too much questions in some cases, there was this distinct rumbling amongst various people, like how much of this are we future-proofing? Almost everybody would have gotten asked this question, right? So why are you asking about this? This is not related to MVP. So my answer to them has always been, MVP means you're restricting the scope of requirements, what you're actually building. Future-proofing is you're anticipating those requirements and building them out in advance, which is bad because lots of synthetic factors could actually change the scope. Cost, resources comes to mind. But on the other hand, asking questions and gaining these deeper insights about the domain mean when you incorporate those into your models become robust, and the software that you build on top of them is more resilient to change. Because the real domain changes very slowly, especially legal domains. Seldom changes, probably for centuries there aren't much changes. So, controversially, MVP is our next near enemy. But it's only in the context of modeling. So when you are modeling and understanding the domain, don't constrain yourself to the scope of MVP. Ask more questions, learn about the domain, but once learned, then restrict to yourself to implementing the MVP. There are always legacy systems in whatever you build. Even in a greenfield project such as ours, we had several discrete legacy systems. So it's always worth keeping in mind that we were working towards the objective of modernizing a criminal justice system, so hardly replicating legacy systems, it won't do. But also, we had to be mindful of when speaking to these domain experts that some of their domain knowledge was actually coming out of working with these legacy systems. So these were legacy ways of thinking that we needed to filter out. So in order to do that, we actually looked directly to the domain. So we went through magistrate court rules, legal documents that were available online, some legislation documents as well to actually gain that domain insight and validate that to filter out the ones that were actually out of working with some mainframe system built like 50 years ago. So watch out for legacy ways of thinking. So obtain knowledge from the current state of domain, how things work, but always model the to-be state, the future state that you want your platform to look like.
So that's the end of part 2. And like we said at the start, what we wanted to do, given the fact that we've kind of hopefully explained quite a lot about the domain that we were working in, we thought it would be useful to share with you some of our upsides and downsides of working with CQRS in this kind of environment, given that we've explained so much about how this domain works. So I get the easy bit, I get the stuff that works really well. So what suited us about doing a CQRS-based architecture? Number one, if you're having to think in a way that you're trying to build a CQRS system, it's a very human-centric way to look at the law. Lots of the ways you need to think in order to think for CQRS design is you think about individual human beings who are individual actors as part of the system, and the legal system, there's lots of individual actors who are passing things around, events, etc., etc. So that worked really well. So you could have conversations with the domain expert, and lots of the language they would use, you could very easily map onto CQRS concepts. Also, because there's lots of individual people, and this is like a long-winded process, and things would eventually become consistent, time and eventual consistency, as we already said, they're baked into CQRS. It's one of the things that you need to think about when you're building CQRS systems. Again, all the domain experts knew that if they changed something, that they'd then have to spend X number of days updating everyone else with the same piece of information. So we would do the same thing, it just might happen faster. And as I said, event-based thinking was at its core. If you ask domain experts in, I guess, any legal system, what can happen next at this stage, and if you want to see like business process modeling, people go white. Just get them to try and model the business process of a legal domain, because there's so many things that happen if this, then do that. Or, some outside external factor happens, like, someone will stand up in the legislature and say something about a law which will then change a bunch of stuff, and then loads of stuff will have to get completely thrown out and started again. All these things. So that's important to have that baked in. And if you're trying to modernize, and this is why CQRS got chosen, if you have time plus events, you get history. And if you're trying to look back, not only can you say, how do we kind of make things more efficient right now with our scheduling? You can kind of query your data. But because you've got all the events, you can query the historical thing. You're like, that crazy thing happened 3 years ago. We've still got the events. We can dial back to that point in time and then model there and see if we can learn some lessons. So that is a ludicrously strong case for doing this kind of approach. It makes so much sense. It's blindingly obvious.
So CQRS in combination with event sourcing, we saw earlier that it imposed a huge constraint if you like that combination, you might want to close your eyes and plug your ears for this part. But we also saw a lot of friction around this area. So first and foremost, aggregates. I believe strongly that aggregates are a classic example of the DDD paradox, which is similar but not the same, because DDD aggregates are subtly different from CQRS aggregates, and it caused so much pain before we actually understood those distinctions. So lack of explicit model in code. This was, again, DDD is all about explicitly modeling and showing that in your code. But with CQRS and event sourcing aggregates implementation, all you see is the aggregate root. The rest of the part of your domain model is hidden and distributed amongst your domain events. Read versus write models. Again, if you superimpose your domain model on top of a read model, it would look very much alike, very nicely canonically formed and branching off. Whereas your write model, in reality, is your domain model because it contains your domain logic, domain events, and it shouldn't change a lot. Whereas read models are transient, depending on how you want to read your the data out of your events and the reconstruction in the future. So that could change. So your read models are not your domain models, even though they might actually look like it. As human beings, I think we are all kind of trained to think in a synchronous way, request, response, command, cause and effect, whereas event sourcing is very much an asynchronous way of thinking, which is very difficult to get your head around. And finally, visualization. This was a constant challenge for us. How do you show hundreds of events flying around between 30 different microservices? The closest I came was to pick up different parts of the process and use sequence diagrams to show the flow of events rather than flow of time. Even that was not adequate. So near enemy in this case is CQRS, and CQRS everywhere, definitely. So we were using CQRS absolutely on the edge, on the interface side, in every possible way. So it's very powerful, only if it is used in the right way. But how do you know what the right way is? So look for clues. Andrew hinted on a few tips to look for in the domain. The domain will actually guide you on what would be the best place to implement CQRS in.
So that's all of the near enemies we've got. We were going to put all of the near enemies on a slide, but it turns out that's quite hard because there's quite a lot of words. So we pulled them together, and I need to do this right. So you can take a photograph. These are the themes, which if these themes seem very close to the kind of fundamental principles of domain-driven design, we didn't do that on purpose, but it's interesting that we kind of took the long way around to get back to all of the stuff that's probably quite fundamentally baked into Eric's book. And the conclusions are these. So number one, slow down and listen. So ubiquitous language is super important, and I really saw the benefit of this, especially for the differences. And this is the thing, it's when you think people are talking about the same thing, but it seems subtly different. Digging into the difference will give you so much information that you'll thank yourself. Number two, work with the code. You can't just do this standing in front of a whiteboard. It'll get you so far, but as Gayathri pointed out, you need to get it to work, you need to take it all the way down to the code. Work as a team. DDD is for everyone. You can't impose it on people. And fundamentally, like super importantly, distill. There's the one section in the book has the word distill in the title. And again, I'd never noticed this. The reason it's there is because you need to have the kind of all of the richness, and then you can distill the key elements from that. You can't just kind of go straight in and know what the key points are to begin with. Next up, investigate puzzles. Because the domain, especially if it's a complicated domain, people will have wrestled, like in the law, for hundreds of years on how to design an efficient system. They just might not have based it on digital technology. So there will be lots of problems and solutions that are already in the domain. Just listen to the experts and they'll tell you how it works. And that's what it says. The domain already knows how to split things up, but it also knows how to solve lots of problems. And the last one, which isn't necessarily in the book, but is something that Gayathri and I found was super important. Distinguishing as is from to be every time you do a modeling session, every time you speak to a domain expert is key to make sure they're not talking about the legacy system you're replacing, they're talking about the law or medicine or whatever you're building. And that's it. So Gayathri and I need to disappear at past, but we'd like to take questions for the next 6 minutes, if anyone has any questions.
Yeah, thanks for the talk. What's exactly the difference in DDD aggregates and CQRS aggregates?
I was hoping this question would come up. So it was very subtle. One important difference that I noticed was how the DDD aggregates focuses on the entities or the child that falls under the aggregate root. So in order to reach the child entities, you have to go through the root, and that kind of determines how the whole aggregate hangs together. So whereas in CQRS aggregates, it's the aggregate root that is important, but also in combination of event sourcing, if you look at it. So for example, for us, case was at the top level, right? So you have to in order to access the defendants or case materials, everything needed the case. So which actually resulted in this case being the only aggregate in the whole platform. But that's not the case, because we wanted to capture events at the defendant level, at the case materials level. So that DDD aggregate definition was strictly going by that, actually caused a lot of problems and probably resulted even in this one case, giant case class. So, but then the realization was, in the event sourcing perspective, you want to capture the events, creational events, modification events for the defendant, because those are very distinct. And again, not to go into the CRUD thinking, it was about a suspect being charged or a defendant being, booked for a first hearing. So those were very distinct, and that was an aggregate in itself. So not to get too bogged down by the strict definition of DDD aggregates.
Any other questions?
We have time for another question or two.
Or we get to go to the airport 5 minutes early.
Okay then. Thank you.
Thank you very much.
Thank you.